At the dawn of the 17th century, humanity stood on the brink of a significant transformation in our understanding of the cosmos. The dusty streets of Middelburg, a thriving city in the Dutch Republic, were the unlikely backdrop for an invention that would forever change our view of the universe, the telescope. Hans Lippershey, an otherwise ordinary spectacle maker, found his life inadvertently steering towards the path of innovation. Born around 1570, Lippershey had dedicated his craft to producing lenses for reading glasses, serving the needs of the vision-impaired populace. Little did he know that his work with lenses would lead to something much greater. In 1608, Lippershey presented to the world a device crafted from wood and leather, housing lenses carefully arranged to magnify distant objects. The telescope, as it came to be known, comprised two lenses, a concave ocular lens and a convex objective lens. For the European merchants and captains seeking tools for navigation and warfare, the potential of such an invention seemed immeasurable. Ships could be seen approaching from further away, and distant lands could be cautiously mapped from a ship's deck. Lippershey's innovation was remarkable not for the complexity of its engineering, but for the revolutionary perspective it offered. Yet, it was not this spectacle maker who would claim the telescope's fame. Across the continent, an Italian mathematician, Galileo Galilei, caught wind of this burgeoning technology. Galileo, a steadfast believer in the Copernican model of the universe, saw in the telescope a chance to substantiate what was, at the time, theories treated as heretical. Galileo's mind was relentless, always in pursuit of knowledge and truth. Upon acquiring a rudimentary version of the telescope, he endeavored to enhance its design, transforming it into a more powerful tool. By redoubling the magnification abilities with a superior arrangement of lenses, Galileo pointed his improved telescope towards the heavens. In 1609, he gazed upon celestial wonders that no human eyes had ever beheld in such clarity: the rugged surface of the moon, the myriad moons of Jupiter, and the countless stars that populated the Milky Way. Every observation challenged the geocentric worldview that held Earth at the universe's center and corroborated the heliocentric ideas that placed the Sun at the center of our solar system. The Church, a bastion of traditional cosmological beliefs, was disquieted by the implications of Galileo's findings. Nonetheless, his discoveries circulated through learned societies and universities, spurring debates and further studies. The telescope had not only opened the universe for study but had unlocked an era of scientific inquiry and skepticism. In the years that followed, the telescope continued to evolve. Johannes Kepler, inspired by Galileo's work, improved the optical design to produce what we now call the Keplerian telescope. Isaac Newton later adapted the device by introducing a reflective model, the Newtonian telescope, laying the groundwork for modern astronomical instruments.